Morning, saya Aziz bin Muhammad Hizir.
Assalamualaikum, saya Muhammad Adil Daniel.
Assalamualaikum, saya Muhammad Afiq Fikri bin Azul.
Assalamualaikum, my name is Muhammad Mubarak bin Zainal.
Kami daripada program Diploma in Welding Technology. Ini kami akan present tensile properties analysis of carbon steel and aluminium. This report present the result of tensile test on aluminium and mild steel. The ultimate tensile strength and yield stress of those two metals were obtained by analyzing the stress and strain curve. Sample of aluminium and mild steel specimen was loaded into a universal testing machine. The machine increased tension force on the specimen and stretched it until failure. The data obtained from the machine was then analyzed and plotted into a stress and strain curve. From the stress and strain curve, the ultimate tensile stress, yield stress of aluminium and mild steel was determined.
Introduction. Tensile test is one of the most widely used mechanical tests. Various properties of materials that can be determined by tensile test are yield stress, upper and lower yield points, tensile strength, elongation, and reduction in area. A tensile test, also known as a tension test, is one of the most fundamental and common type of mechanical testing. A tensile test applies tensile force to a material and measure the specimen response to the stress. By doing this, tensile test determine how strong a material is and how much it can elongate. Tensile tests are typically conducted on electromechanical or universal testing instruments, are simple to perform and are fully standardized.
Objective, state your objective of experiment. Number 1, to develop an understanding of stress strain curve. Number 2, to find tensile characteristic of material, how the material react when pulled apart. The material property are normally recorded and calculated.
Result and discussion. Specimen 1, aluminium. Before test, initial thickness 3 mm, initial width 12 mm, initial area 36 mm, initial gauge length 60 mm. After test, final thickness 3 mm, final width 11.6 mm, final area 34.8 mm, final gauge length 73 mm. Specimen 2, mild steel. Before test, initial thickness 3 mm, initial width 12 mm, initial area 36 mm, initial gauge length 60 mm, and after test, final thickness 3 mm, final width 11.3 mm, final area 33.9 mm, final gauge length 65 mm. The data obtained from the tensile testing machine shows the difference in rates of extinction in mild samples. When subjected to same amount of load, there was relatively high extension aluminium than in mild steel. There appears to be a clear difference between mild steel and aluminium material upon completion of the result for the experiment. When talking about mild steel material, its ability to hold maximum load, which is 260.864 MPa, when compared to aluminium, which can hold 158.484 MPa. Also, mild steel tensile strength 9,391.4 104 MPa is greater than aluminium, which is 5,705.424 MPa. Mild steel also has greater elasticity, meaning it is more brittle.
Methodology. Specimen have to cut into a dog bone shape, measure the width and the thickness. A material is gripped at both ends by an apparatus, which slowly pulls lengthwise on the piece until it fractures. The pulling force is called a load, which is plotted against the material length change or displacement. The load is converted to a stress value and the displacement is converted to a strain value. Conclusion. From the tensile test experiment using tensile test machine, the mechanical properties of a material can be obtained. When the material is being stretched, it experiencing elastic and plastic deformation. The strain hardening phenomenon is occur when the material is getting stretched until it goes to fracture. From this experiment, steel and aluminium give two different mechanical properties. Steel and aluminium have a different strength coefficient since steel has high tensile stress and aluminium. The value that obtained from the experiment is quite accurate because of the approximation of plot from the raw data that generated by the machine. That's all for our presentation. Thank you.